Remember when I told you no matter where I go, I'll never leave your side, you will never be alone, even when we go through changes.
Now let's talk about softening. Under this, we have 4 subtopics. First one is hardness, second is lime softening, third is the more advanced concept in lime softening, and the fourth one is the ion exchange softening. Let's start with hardness. The term hardness is used to characterize a water that does not lather well, causes scum in the bathtub, leaves hard white crusty deposits, also known as scales, on your coffee pots, tea kettles, and hot water heater. As a result of this complexation reaction, soap cannot interact with the dirt on clothing. The calcium soap complex itself forms undesirable precipitates. Hardness is defined as the sum of all polyvalent cation. Although all polyvalent cation contribute to hardness, the predominant contributors are calcium and magnesium. Thus, our focus for our discussion today will be on calcium and magnesium. Now, what you can see is the hard water classification, hardness range. If it is 0 to 75, that is soft. For this description is soft. When it is 75 to 100, that is moderately hard. But when it reaches 100 to 300, that is considered hard. But when it becomes bigger or greater than 300, that is considered as very hard. Since we've already talked about hardness, so now it's time to know how to get our total hardness. So all we need to know is, first is the calcium and the magnesium. Just add it together to get our total hardness, which is denoted by letter T, big letter T, and H. Other way to get our total hardness is to just add our carbonate hardness and non-carbonate hardness. There are 2 components of total hardness. The first one is the carbonate hardness, or CH. This is what we call the temporary hardness. It is associated with the HCO3 anion. The second one is the non-carbonate hardness, or the NCH. This is what we call the permanent hardness. It is associated with other anion. Carbonate hardness. Carbonate hardness is defined as the amount of hardness, which also known as the total hardness or alkalinity, whichever is less. If the pH level is less than 8.3, total alkalinity is taken to be equal to the concentration of HCO3 negative. On the other hand, we have the non-carbonate hardness. Non-carbonate hardness is the total hardness in excess of the alkalinity. If the alkalinity is greater than or equal to the total hardness, there is no non-carbonate hardness. We have here the problem. A water has an alkalinity of 200 mg per liter as CaCO3. The calcium concentration is 160 mg per liter as ion, and the magnesium concentration is 40 mg as ion. The pH is 8.1. Find the total carbonate and non-carbonate hardness. So, natay tulod diri ka ng formula nga kailangan nato i-remember. Ang kani siya sa total hardness, ang total hardness, o kani siya sa total hardness gihapon. Pero mo sa ito na-mention ako a while ago. So, nakanote na diri ang mga values na naa sa tong problem. The molecular weight of calcium and magnesium are 40 and 24 respectively. Since each has valence of 2 positive, the corresponding equivalent weight are 20 and 12. So, 20 para sa atong calcium and 12 para sa atong magnesium. So, importante nga makita nato ang atong equivalent weight kay magamit nato siya sa pagkuha nato later sa atong TH. Using this equation to convert mg per liter as ion to mg per liter as our CaCO3 and adding the 2 ions as shown in this equation, the total hardness is 160, so ito dere, 160 mg per liter times our 50. Ang 50 kay siya man ang equivalent weight of CaCO3. Kaya remember, kani ba itong gamiton na formula? First na itong unang gamiton. So, let's do it. Ang 160 mg per liter, i-times din mo siya sa 50 mg per mech. Close in parentheses, over kaning sa 20 nga calcium. 20 na equivalent weight. Plus, bali, di ba mao ni ang ato ang pangduhang equation, pero isahon na nato siya. Ang kani siya, mo na siya atong ginabuhat diri nga part. Tapos mo na nag-add ta kay first sa calcium man katong first atong gibuhat. Then for the second one mo na pud next atong buhaton. For our magnesium, so since ang magnesium concentration is 40, so magbutang tag 40 diri. 40 mg per liter. Tapos times na po nato siya diri sa ato ang sa magnesium, di ba kay equivalent weight niya is 12. So butang nato 12 sa ilalom. Tapos sa taas kay mo gihapon 50 gihapon kay mo man na siya to equivalent weight for of CaCO3. Now i-calculate na nato 160 parenthesis 50 over 20 that's equals 400. So butang 400 sa calcium nato na tapos sa magnesium na ta. So ara 40 50 over 12 that is 166.6 166.67. So yan. So ato na siya i-add sa 400 166.67 plus 400 that is equal to 566 or 6.67 or 567 milligrams per liter as CaCO3. Pero what dili pa dira nag-end kay since ang mangitaon man nato ang total ang carbonate o non-carbonate hardness. So karon pangitaon na natay total hardness. So magamit nato ni siya para pangitaon si carbonate hardness o si non-carbonate hardness. By the definition, the carbonate hardness is lesser to the total hardness or alkalinity. Since in this case, alkalinity is lesser than our total hardness, kaya diba, ang alkalinity nato dito sa problem is 200 siya, which is less than siya sa ato ang total hardness, which is 567. The carbonate hardness or our CH, atong ginapangita, CH is equal to 200 mg per liter as CaCO3. Kaya di ba naka-note ganina, so gi-discuss na ko nga ang pH, if ang pH is less than 8.3, ang total alkalinity, kani sa taas, if CH defines the amount of hardness, or ang total hardness or alkalinity, so mamili lang ka dira, dito ka mag-base kung kinsa ang mas gamay, since mas gamay man ang ato ang alkalinity which is 200, so mo na ang atong alkalinity diri karon, or ang CH nato is 200, kay bali siya itong equal sa CH nato kay siya man ang mas less. The non-carbonate hardness is equal to the difference of the total hardness minus our carbonate hardness. Since naman tayo formula ganina, gipakita na ako itong third formula nga kailangan i-remember kani, where TH is equal to CH plus NCH. So i-rearrange lang nato na siya, mahimo na siyang NCH is equal to TH total hardness minus our CH. Ang CH na tumayo sa itong carbonate hardness which is 200. So mo siya ang total hardness, carbonate hardness. So total hardness is 567. I-minus lang nato siya sa itong CH, carbonate hardness na 200. So 567 minus 200, and that is equal to 367. So ang atong non-carbonate hardness is equal to 367. So ara na atong answer, ang atong CH or carbonate hardness is 200 and non-carbonate hardness is 367 mg per liter as CaCO3.
Softening can be accomplished by either the lime soda process or by ion exchange. In lime soda softening, it is possible to calculate the chemical doses necessary to remove hardness. Hardness precipitation is based on the following two solubility. For calcium, pH is 10.3. For magnesium, pH is 11. Flow diagram of solving softening problem.
So this flow diagram will help us later on with our problem.
Our problem is, from the water analysis presented below, determine the amount of lime and soda in milligrams per liter as CaCO3 necessary to soften the water to 80 mg per liter hardness as CaCO3. So, mo nitong water composition. So, ang first step nato is First thing we need to do is to convert elements and compounds to CaCO3 equivalents. So ganina napakita na nako kung paano mag-convert og elements to CaCO3. It is by using this equation, mg per liter as CaCO3 is equal to the mg per liter as species times the equivalent weight of CaCO3 over the equivalent weight of the species. So muna siyang gamiton. So muna ni ang elements o compounds pag na-convert na siya to CaCO3. As you can see, our calcium nato is 238 at ang magnesium is 55.37 and so on and so forth. Muna siya itong values. If ibutang nato siya sa chart, no, sa bar chart, muna yung itsura. Ara ang CO, ara ang Ca, and so on and so forth. Ibutang lang siya. So this is our way to determine the lime dose. Since ang atong pangitaon is lime and soda, let's start with lime first. So ang lime, nadiri ang ato ang guide, nadiri atong mga given. So mag-add daw ka og lime na CO2 ara, which is muna itong number 1 guide. And next is mag-add apod ka og HCO3. Since sa ara sa first part nato nag-add tag CO, ang CO nato ang value niya is 44.14. Sa second ang HCO is 198. Na siya dito sa values ganun akong gipakita. Which is na adiri arang HCO kani 198. Tapos ang ato ang CO2 ara 44.14. So mo na atong gamiton. And ang next step after adding, di ba tanawon ninyo, na question na to ma-encounter is Mg or ato ang magnesium is greater than 40. Tas ang magnesium man nato kay, as you can see, after converting our magnesium has a value of 55.37, which is greater than 40. Following the step, if yes, as you can see here, if it's greater than 40, if yes, add lime. Add lime is equal to Mg or magnesium minus 40. That's why nag-add tag isa ka lime diri kanang ka third part. Mo siyang third part. Then nanapod tay ato ang question na ma-encounter, which is ara is magnesium minus 40 is greater than 40. Di ba pag ano nato ni siya ang answer ani kay this is equal to 15 point something. 15.37 to be exact if we minus our magnesium to 40. The magnesium result to 40. So now, sa ato ang question diri, dapita, if ang Mg daw minus 40 is greater than 40, of course, no atong answer, no? 15.37 man to. Tapos, napay another question. Ara, kani. Is magnesium minus 40 less than 20? Yes, less than 20 siya. Muna, mag-lead ang arrow sa pag-add og lime is equal to 20 mg per liter. That's why sa atong fourth step diri natay lime excess. Muna siya itong gi-add na 20 mg per liter. Since napay another arrow, i-follow na po natin na ang arrow na i-lead sa question na is there NCH to be removed. Since wala man no na, so ang no na arrow i-lead na to stop. So diri na mag-end ang ato ang pagpangita nato. So i-add lang nato ni sila ang kaning 277.5 muna siya ang ato ang amount of lime to add. Muna siya tong amount of lime to add. 277.51 mg per liter as CaCO3. Di sa ilalim na part, makita nato diri ang ato ang TH, no? Ang TH, tong total hardness, as you can recall, I mentioned ako a while ago na ang pagkuha sa TH is equal to our calcium plus magnesium. So, pangitaw na nato ang amount sa atong calcium nga nadere og ang magnesium, equivalent sa magnesium, and then i-add nato which is muna siya tong total hardness. Ang CH nato naman na siya dito sa given, ang CH. Ara siya dira. Ara tong CH kanang 198. As you can see, HCO3 actually associated mo siya dito ang kanang CH og HCO associated na sila together. So, yeah. Na-explain ako na a while ago. Tapos, ang next is our NCH or non-carbonate hardness is equal to our TH kaning 293.37 i-minus lang nimo sa 198 and that is 95.37 as mg per liter as CaCO3. So na naman tayo amount of lime to add ganina to 277.51. Now we must determine if any NCH need to be removed. The amount of NCH that can be left is equal to the final hardness desired, minus RCH left due to solubility and other factors. Kaning 80 diri muna siya tong final hardness desired na naagani na sa problem. Ang kaning 40 muna siya ang atong other factor. Kaning 40 nga na diri So 80 minus 40 is equal to 40 mg per liter. Thus 40 mg per liter may be left. The NCH that must be removed, or denote as NCH, subscript R, is the initial NCH minus the NCH na can be left. So karon, ang ato ang NCH na to be removed is equal to 95.37 minus 40. If you wonder kung asa ka na 95, mo na itong pinakauna natong gi-calculate na NCH. Which is 95.37. Tapos, i-minus siya sa katong second natong i-calculate kani NCHF, which is equal to 40. Mo ng 95.37 minus 40, which is equal to 55.37 mg per liter. Thus, the amount of soda to be added is 55.37 mg per liter as CaCO3. The fact that this number is equal to our magnesium concentration is just a coincidence of the numbers chosen. So that's it.
Now it's time to go to the more advanced concept in lime softening, estimating CO2 concentration. CO2 is of importance in two instances in softening. First one, it consumes lime that otherwise could be used to remove Ca and Mg, or calcium and magnesium. Number two, or the second one, is CO2 is used to neutralize the high pH of the effluent from the softening process. Split treatment. In split treatment, a portion of raw water is bypassed around softening reaction tank and the settling tank. Now we have here the function of split treatment. First, it allows the water to be tailored to yield the product water that has 0.80 mEq per liter or 40 milligrams per liter as CaCO3 of magnesium or any other value above solubility limit. Second, it allows for reduction of capital costs of tankage because the entire flow does not need to be treated. Third, it minimizes operation costs for chemicals by treating only a fraction of the flow. Fourth is it uses the natural alkalinity of the water to lower the pH of the product water and assist in stabilization.
The fractional amount of the split is calculated as X is equal to MgF, or final magnesium concentration, minus magnesium concentration from first stage over raw water magnesium concentration minus magnesium concentration from first stage.
Ion exchange softening. Ion exchange can be defined as the reversible interchange of ions between solid and liquid phase. In water softening, by ion exchange, the water containing hardness is passed through a column containing ion exchange material. The hardness in water exchange with an ion from the ion exchange material. Generally, the ion exchange with the hardness is sodium, as illustrated down below, where R represents the solid in ion exchange material. Two types of ion exchange material. The first one is naturally occurring clays called zeolites. Second is synthetically made resins, which has a higher exchange capacity and it requires less salt for regeneration. Since the resins remove virtually 100% of hardness, it is necessary to bypass a portion of water and then blend in order to obtain the desired final hardness. The percentage of water to be bypassed is found using the equation below. Percent bypass is equal to 100 times hardness desired over hardness initial.